perspective drawing for debutantes. If you don't know what a debutante is, it's just a fancier way to say beginner, and you may be thinking, hey, that has nothing to do with perspective, and I'm like, yeah? Well, you're here to learn things, so if nothing else, you just learned a new word. I taught you that. I did. Anyway, we're going to talk about perspective drawing, but first, it's important to understand that perspective itself is a concept, not a practice. In reality, you'll be using constructive drawing skills to build objects in 3D space, and then applying the concept of perspective to it. But what the heck in heck does that mean? Here's the time lapse of what I mean as an example. It may look complicated and challenging, but I'm actually just using like 5 or 6 different drawing techniques that have nothing to do with perspective itself, and those are the things I'm here to teach you. We're going to start off by working in 2D and add more dimensions as we learn more things. Begin by drawing an equilateral rectangle. We have a few things to find here: its center point, its scale factor, and its ability to multiply. To find the center point, just draw an X from corner to corner. Congratulations! Now, if you extend that X out to wherever, you get a guide that allows you to draw new rectangles that are proportionally larger or smaller than your base. Note that this also works with non-equilateral rectangles. Ha! See? It was important that I called it a rectangle and not a square. It came back! You have to believe. So now that we have our center point, we can also easily divide our base square into vertical and horizontal halves, and that gives us the ability to multiply. Let's say we want 3 squares of the same size and can't measure it for whatever reason. First, extend the edges of the square where you want your new ones to be. Draw a guide from the opposite corner, passing through the midpoint until you hit the intersection, and then draw a vertical line from there to complete the square. And finally, repeat the same steps to get the last square set up. Et voilà, bien joué, nous avons 3 carrés. Let's go back to 1 square so we can take a look at how to symmetrize information. Yeah, let's do that. Say that you have a neat pattern on one side of your square and you want to copy that over to the other side, but you're doing this on paper so a computer can't save you anymore. You can find the points of that pattern using the same tools as above. If you treat each point as the corner of its own box, you can then find its buddy on the other side. Cool, huh? You can even do that with curves, but we're not going to talk about curves in this video because that's its own therapy session, and I get paid by the... I don't get paid for this. Please join my Patreon. Here's the bonus tip. If you want to divide a square into thirds, which is useful for a lot of things, like if you want a rule of thirds composition for your image, draw 2 parallel diagonals from a corner to the opposite midpoint. The places where the lines intersect fall right at the third division, both vertically and horizontally. It is neat. And now, believe it or not, you more or less have good enough tools to get started on building stuff in 3D. So let's add a dimension and build some things. The Z dimension. I mean, it could be Y, I guess, but Z sounds cooler. We are going to draw what's called an isometric grid, which is a way to visualize 3D space without having to worry about foreshortening. Foreshortening, for the uninitiated, is the thing that makes objects look bigger when they're closer to you. To do this, we're going to draw some parallel lines going one way, then we're going to do some more going more or less the opposite way but in a different color. A good rule of thumb for this is to also have them at noticeably different angles, so like 11 and 2 o'clock is pretty reliable, and finally add a bunch of vertical lines in a third color. Each of these sets of lines represents an axis in 3-dimensional space. So go watch a movie in 3D, steal the glasses, and I'll wait here. Psych! I'm not waiting. You can pause the video for yourself. Moving on, we haven't actually changed the way in which we do any of our drawing tricks. We're just doing them at an angle now. So let's practice that by adding a new rectangle in there. And unless you're an architect, just eyeball it, it's fine. In this case, what's important is for the edges of the rectangle to be parallel with your grid lines. Add some vertical lines at the corners, and then add another rectangle, which, because of isometric projection, will be identical to the first one, and suddenly we have a box. And now watch as the exact same drawing techniques translate over. Want another box? Do the multiply trick. Find your X, draw out a line from the center that's parallel to these new guides, extend the box. Want a smaller box sitting on top of the original one? Draw a scaled down rectangle on one of the sides and extend it just like we did with the original one to make it into a box. It's all just the same techniques and you can repeat them forever. Going into detail at this point is really just a matter of using the same tools but on a smaller scale. As long as the things you draw line up with the guide grid, things should start looking pretty good over time. This is also a great way to conceptualize little scenes and stuff, and I'm going to show you an example here so you can see it in action. Chapter 4, I think. I'm gonna slow down here because this is where things get stupid. I just gave you a sufficient handful of drawing techniques to do everything that's coming up, but drawing in perspective is less about technique and more about understanding how perspective do. I will show you other techniques in a bit, but first let's go over the conceptual stuff. Horizon lines and vanishing points. Heads up, don't let the names of these so-called things that exist fool you. They're lies. And we're going to talk about that. But before that, let's go over what they do so you get an understanding of how to work with them before I make everything so much worse. A horizon line, and I cannot emphasize this enough, is not a physical horizon. The purpose of a horizon line is to help you measure heights in relation to where the line is placed, and in terms of actually drawing an image, that is its only function. I can't explain why just yet because it wouldn't make sense right now, but please keep that in mind because a lot of people, myself included, misunderstand it for a long time and it will get in the way of your work. You can visualize the horizon line as a line that you can trace between a person's eyes. So for now, I want you to pretend that for everything I explained, you're looking out forward toward the physical horizon on a level plane, not looking up or down at all, just forward. That's important. From this vantage, anything under the horizon line is below or shorter than you, and anything above is higher or taller than you. That may sound obvious, but trust me, it's not. And we find where those things are in space relative to where you are by using vanishing points. Remember how on the isometric grid we had one axis going in one direction and all the lines going in that direction were parallel? Well, a vanishing point is when you take those lines and make them converge at a point on the horizon line. So all the things we learned earlier still apply, but now any lines that you draw that are meant to be parallel to each other will meet up at a point on the horizon line. So keeping the same color coding for our grid, we're going to take a look at how that all works together. Here's a horizon line, here's two axes, vanishing points. So now I'm going to do another little time lapse here so you can see all the things you've already learned working with this new setup. Neat, yeah? But there's some issues here that'll make some of you want to quit and give up on the whole thing, and I want to talk about those. For starters, every single point where your axis lines intersect is a 90-degree angle in 3D space. And I know, you might be thinking, hey, that's a really acute angle for 90 degrees, and you're right. So right, in fact, that if you draw a box there, it'll look real janky, and you'll kick yourself later, right in the self-esteem. Don't. Explaining why that happens is a little tricky, so I'll make it easy and just tell you that for practical purposes, it just means that your vanishing points are too close together. So if you're looking at a piece of paper and you're running into that issue, just spread them out. I actually have another video specifically on how to set up perspective grids and avoiding distortion, and I'll put a link to it in the comment thingy, so check that out if you're curious, but really other than that, it's all basically the same few drawing tips I gave you at the start of the video. Okay, now we can look up and down. A little bit. Step 1. The horizon line's placement determines whether you're looking up or down. To look up, lower the line. To look down, raise it. But, as we discussed a minute ago, stuff starts looking all wonky if you draw too far up or too far down from the vanishing points. The way we fix that is with 3-point perspective. And what that means is when you have your regular 2-point setup like we've been using, but the vertical lines on your grid also converge at a point on their own. Where is that point? Well, usually it's directly in front and up from your vantage point, but you can put it wherever you want. I'm not your mom. How far up you place it determines how much distortion you'll get on your drawing. I recommend doing like a loose sketch before you plan out your perspective and then adding your guides so that you can clean everything up nicely. The same is true if you're looking down, but there is a catch. The 3-point perspective relies on the idea that you're still generally looking forward toward the physical horizon and just observing things that are higher or lower than you. If you look up or down far enough, you actually unearth the first lie of perspective drawing. If you look up at the sky to see skyscrapers, your vantage point has actually shifted enough that the physical horizon ceases to be relevant. Drawing an upshot looking at tall buildings from the ground level is identical to drawing in 1 or 2 point perspective. The only difference is that the physical horizon is no longer a thing, and your horizon line is now just an invisible line somewhere in the sky. Whoa. So the takeaway here should be that 3 point perspective is a very specific tool you can use when you want to draw extremely tall or deep things relative to your vantage point, but in 90% of cases it's actually completely unnecessary. In fact, 3 point perspective only came around as an idea after skyscrapers were becoming a thing in like the 1930s and 40s, so the concept's actually been around for less than a century. Think about that. Anywho, by now you kind of understand most that there is to understand about this. It's all just a matter of practice. So, it's time for rapid fire drawing tips and tricks. 1. Vanishing points only refer to the axis of one box, not the foundational essence of the universe. If you have a street and you want to draw an inconsiderately discarded trailer in the middle of it, forget the original vanishing points. You can draw up new ones, and oh my god, suddenly you can draw things at different angles. What? You mean vanishing points aren't a real thing and you can have as many as you want in order to help you draw anything without it all being aligned to the same grid? 2. No, if you're drawing like a building that's a hexagon, you need at least 3 vanishing points on the horizon line just to draw the shape to begin with. So use as many as you need to make whatever needs to happen, dude. 2. Point B. I know I'm beating a dead horse at this point, but I can't stress this enough. These things aren't real, and if you wanted to draw like a plane or a spaceship at an angle that's different from a city in the background, that element is going to need its own horizon line and its own set of vanishing points completely separate from the rest of the image. It's important. Please remember it. 3. How to heights. If you measure the height of something against the horizon line, you can keep drawing things of the same size. And if you need a person to be like offset, you can find the point where you want that person to be standing and then intersect that against the height you're measuring against another vanishing point. But are you too lazy to measure all of that? That's okay too. Just try and remember that if a person's head and feet are below, above, or bisected by the horizon line, all other people, on average, should have the same rough scaling. Note, this only applies if the people are on the same level as you, not if they're physically standing below or above you, and that's a little advanced, so that's a subject for another video. 4. Need to draw a complicated pattern, but trying to get that all aligned on perspective is really difficult? Easy. Draw it straight from the front first, and then you can draw horizontal guides that turn into vanishing point guides so everything is aligned properly and cool. You can use it to draw clocks and windmills like they did in that one anime show, so you can do it too. 5. Do you need to divide something by a specific number of sections? Well, same thing-ish. Draw a line with the right number of divisions somewhere close by, draw lines between the ends of your new line and the line you want to divide until those two lines intersect, and then use that as a temporary vanishing point to figure out where the divisions would happen in perspective. Oh my god! 6. Shingles. Like the ones you see on the rooftops of houses, not the ones you get if you think about American politics a little too hard. Hey! First, find the box for your building, then extend the sides that's going to be higher and draw diagonals that meet their respective corners. Use those two new diagonals to find, you guessed it, a vanishing point. This one's neat because it's not even on the horizon line, it's just off somewhere vibing in space. But the relevant thing is every single line that you draw going to that vanishing point now will be perfectly aligned with every area of that roof. You're amazing. 7. Clouds don't exist in perspective. They just don't. They're too big. You cannot comprehend how big clouds are. They just do not exist in perspective. Don't even try. 8. I know this is a lot, but if you have any questions about any of what we've covered so far, you're welcome to ask. I will be making more videos about finer details in the future, but now it's time for the truth. Everything I've taught you up to this point has been false. It is a testament to the arrogance of mankind, and it's time we accept this and look at the reality of the universe for what it is. This thing you're looking at, this ground plane with that horizon line, it's all it's not real. And I don't mean because it's like on paper. I mean that there's something about perspective drawing that no one has ever told you before. And it's that this plane does not represent the Earth. Because I don't know if you know this, but the Earth is not flat. And I'm not just talking about how the Earth is covered in like mountains and hills and valleys. I'm talking about how it's like a sphere. Okay, well, it's not actually a sphere, it's an oblate spheroid. But the point is, if you're standing on solid ground and you look off to the horizon, even a particularly tall person can only see about 3 miles away before the curvature of the Earth dictates that you just can't see more things ahead of you. 3 miles. That's not even that much. You lose miles way more than 3 times in your average Sonic the Hedgehog 2 level. But when you look upon that plane, you're seeing a reality in which buildings could theoretically shrink into eternity because this plane does not account for the curvature of the Earth. It never ends. What can we learn from this? Well, for one, it just means that instead of treating the horizon line as the physical horizon, you should think about putting like the physical horizon somewhere slightly below the horizon guide, and then also add hills and mountains for a more convincing effect. But think about it. When you look up at the stars, they're not even there anymore. They haven't been there for millions of years. What you're seeing is the light that those stars cast millions of years ago and is only now reaching our eyes for the first time. But we have to acknowledge what's really at stake here. If you set up an infinite pillar of light emanating from a random point on Earth, it wouldn't just look like a spire that eventually gets too small to see. No, what would happen is thus. As the Earth travels through space, that straight beam of light, such as it is, will actually curve over time, as the light that was cast earlier takes longer to reach us. So once the beam of light gets a few million light years away from us, if we looked up at the sky at night and looked at the infinite beam of light, we would actually see a curved line, and it wouldn't just be like a halo around the world because Earth isn't just rotating, it's also moving around the sun, and the sun itself is moving around the universe. So we would actually see a light spiral stretch out infinitely through the void of the universe around the Earth and ultimately probably coating the entirety of our sky in infinite light. So, this plane, this horizon line, isn't real. Vanishing points aren't real. This isn't real. But, okay, for the sake of argument, I'm going to go ahead and I'm going to do what all of those false prophets from the Renaissance era could not and draw a perspective accurate world based on that plane of infinity that they so grossly mischaracterized as the truth. I'm going to do it. Infinity, here it goes. I'm going to do it.